Welcome to Vision to Venture. I'm Eddie, and I'm here to uncover the realities of scaling and building a tech startup. Each week, I speak to leaders within the tech space with their insights and advice on how to found, fund, and frame a tech startup. So make sure to follow and subscribe to never miss an episode. Hello, and welcome to another episode of Vision to Venture. Today, I'm joined by Petar Todorov, Director of Data Science at Kpler. Kpler is a fast-growing data and analytics firm on a mission to build one platform for global trade intelligence. Peter leads a team of 40 data scientists at Kpler, working on the maritime domain and commodity trading. How are you, Peter? How are you doing today? Thanks for joining.
I'm great, thanks.
So let's just start with the beginning of your career, essentially. You did Masters and PhD in astrophysics. What was it like experimenting with machine learning techniques during your PhD, and how did that shape your career path?
Well, indeed, my first encounter with machine learning techniques was during my studies in physics and mostly in the signal processing classes. Back in 2010, when I was doing my master's, machine learning was taught only in computer science departments, and what was taught in physics department is signal processing. If we define data science as the industrial application of machine learning and adjacent statistical methods, well, most of the fundamentals were there. I'm thinking about regressions that require a regularization that not always go well, and so on and so on. Of course, in signal processing for physics, the focus naturally is on physics important methods like Fourier transforms that are ubiquitous in numerical physics and data processing, and are still essential in industrial data science applications like getting seasonality for time series. However, rather than the individual techniques, what I think is most important for me from this period is the scientific mindset that comes with a PhD in a quantitative field. And this is still very important to me as a data scientist working in an industrial setting. I still believe this is an invaluable skill set, and doing the PhD is the iron way of acquiring this critical thinking mindset. And now, most importantly, in physics, I have learned that all models are wrong, but some models are useful. And this is a very good guideline when I'm interacting with my teams and on the applications, machine learning applications I'm working on.
And so, how would you say the evolution of machine learning from academia to industry changed over the past decade? And how have you adapted to these changes as well?
Well, you usually quit academia only once, so I can't objectively compare quitting academia in 2013 and 2024. However, in my subjective perception, 10 years ago, data scientist was a much more loosely defined skill set, and on this point, the switch was somehow easier. Now, hiring managers, including myself, expect from candidates a well-defined technical stack in terms of machine learning libraries, methods, and also skills in adjacent engineering fields like cloud and platform engineering, MLOps, and understanding, of course, of the business, at least on a basic level. And the more is better, of course. But on the other side, with the explosion of the machine learning application in industry, and from what I follow from my peers who stayed in academia, many graduate programs are now emphasizing using machine learning in academic settings. So actually there is movement in the bridge in the two directions, not in terms of people going back to academia. I think it's a pretty rare case, but exchange of idea, which is very healthy. And also, if memory serves me well, 6, 7 years ago, we've got the release of TensorFlow to the large public and making it open source, and PyTorch. So I'm very happy to see the bridges between academia and the industry being more solid than ever. And of course, I've taken the example of of Google's decision to make TensorFlow open source, which really has a huge impact on both sides.
Okay. And do you think there are any significant gaps that need to be bridged in regards to the transition from academia to industry?
Yes, definitely. There are some gaps. There is a very solid common skill set that I have mentioned regarding the critical thinking mindset, the scientific mindset and approach. However, academia and industry have different goals and different objectives, and it is normal for a professional who makes the switch to adapt. Let me take a simple example. Application of machine learning in academia are usually not meant to be used by thousands or millions of users, right?
Right.
This doesn't make them less valuable. It's just not their objective. However, these simple remarks entail some significant consequences. It implies that in an industrial setting, you should be able to deploy and let your model to be executed in a cloud environment. Hence, you need to acquire some adjacent skills in what we call now MLOps. And you should be able to show that you care about what happens in production when the machine learning application starts facing users. It is not about making a great prototype. This is the objective of academia, usually in academia. Make a great prototype, make a great paper out of it, prove a point, move forward the field. In industry, you have to make an application that faces thousands and millions of users, and it goes with its own challenges. So the difficulties here is twofold. First, of course, there is the pure software engineering challenge of monitoring whether the script that embeds your machine learning models is throwing errors. This one is pretty obvious. It does not require machine learning skills. Second, there is a specific challenge regarding machine learning applications, which is, of course, detecting data and concept drifts, which is hugely important, which could make that your perfectly fine model becomes, less useful over time. Also, going to scale is another axis on which professionals who are contemplating moving from academia to industry should think of, is that going to scale comes with challenges. And also, this is, the downside is, of course, acquiring additional skill set in engineering. But the upside is, of course, that academic folks' solid understanding of statistics is crucial in understanding what happens when the model is delivered to the end user. Also, I would say that some of those thoughts are true not only for data scientists coming from academia, but for every young professional that builds a solid skill set in machine learning, in modeling, in creating models. What courses are usually teaching you is how to build your models, how to fine-tune your parameters. This is only part of the story. Think about what happens when your model is delivered to the client and hits production. And this is really what makes a huge difference between professional. Also, I think that this is really a heavy task for data scientists because in the center of our skill set is modeling and prototyping. Yet we're, however, expected, to bring our models to production and not just to deploy and run the model in a cloud environment and my job is done. It is deploy, run, and observe. So it's all about caring, observation, monitoring the production is what makes a data scientist highly looked upon in professional industrial data science team.
And so you have a strong background in NLP, especially obviously before the introduction of large language models like GPT-3. How has this expertise helped guide your career as well as the team as well?
First of all, large language models are a feat. The first time I touched ChatGPT, I told myself, I wish my NLP models that I'm making were that good.
Yeah.
I was just chatting and, you know, like everybody, putting text, ChatGPT extract insights from here and there, what is said here, what categories, this and that. It's an amazing feat. So there is absolutely no doubt that there is an incredible work done by teams at companies like OpenAI, Meta, Mistral, and other companies that produce models. But what we need to remember is that large language models are language models that are large, right? And they are, first of all, machine learning models that have, those are objects that behave like machine learning models, like neural networks. So wherever my past experience helps me for sure is bringing me a dose of healthy skepticism about what generative AI could bring to the customers. So let me be more concrete. You know, when a large language model generates a phrase, there always be a next token, right? For which the probability of being the next token is the highest. Hence, LLM will always give you an answer to your question. And this answer depends on the corpus it's training on. This is obvious to me for the first time I touched ChatGPT, but it took a few weeks of people unaware of the usual behavior of machine learning models to realize that, surprise, LLMs could hallucinate, right? So let me be even more concrete. Let's imagine asking an LLM, which is the last digit of pi. Any LLM is told that the number pi, what is this? Because somewhere in its training corpus, it's written pi equal 3.1415926.
Yeah.
Or there is some representation of in a DB, in a database saying number pi equals this. But this representation of the number pi in computer memory is finite. And any sufficiently powerful LLM will understand the last digit of pi as the last digit in the finite representation in its corpus, or backend database, or whatever. Now, there might be a level of heuristics in the environment in which the LLM is wrapped, be it RAG or something else. RAG is retrieval augmented generation, which is a common architecture now. I will speak more about this later. But, well, let there be a heuristic layer that is saying, like an if-then loop, checking if the user is asking about irrational number and saying, no, there is no last digit of pi because it's an irrational number. I'm giving this example as an illustration of the affirmation an LLM is always answering. And this is what people who try to make good use of LLM should be aware of. Now, I'm giving this example because this joins nicely with the previous question. In Kpler, we are developing an LLM-based solution for a few months now.
Okay, nice.
And we could have released it by now, but without modesty, we have set the bar pretty high for ourselves. We want an LLM-powered feature that provides clear and measurable value for the customer. We are in a classic explore versus exploit dilemma right now. How long should we develop before releasing? And, you know, let me share some thoughts with your followers. We have, of course, first prototype. We made an internal test, putting a limited scopes of our data in a vector database dedicated to the RAG and released to internal users. However, the main teaching of this was the internal users did not feel restricted by the scope of the POC and were expecting a ChatGPT-like setting that knows all of Kpler's data. Well, those are internal users. Now imagine what would end users do, right? They will. I think my conjecture, they would feel even less restricted. As Kpler sits on a wealth of data, building a RAG on a heterogeneous base can be challenging. So we kept the bar high and decided to release when the feature provides a clear value for the end user. You know, rather than restricting on a very limiting use case and telling the end user, okay, this is a very restricted case in which our RAG provides meaningful results. Please don't use it for something else. I think this simply could not work. And last but not least, I have observed that several well-known companies who surfed on the LLM hype have rapidly deployed RAG-powered features in production, features like conversational agents, and they're now silently retiring them. You know, I'm not going to shame colleagues from other companies here, so I'm not citing anyone, but let's just reflect on why this is happening. Well, in my humble opinion, this is precisely because of what I've discussed in the previous topic. Ahead of releasing any pipeline, using ML models based on, name it, XGBoost, neural networks such as transformers, language models, large language models, we have to have in mind that they have common patterns of behavior that are characteristic of machine learning models. And if you wish the success of your feature in production, you have to care. You have to care about your pipeline, how it's facing users, being able to monitor your pipeline, and determining what kind of questions your users are answering and asking. This is how you can really gauge if your RAG is performant in real life situations.
Mhm. Okay, and so Kpler's work spans a wide range of data science applications. So could you discuss some of the key projects that your team are working on and their impact on the maritime and commodities trading sectors?
Yes, sure. One of the most exciting things for me, well, maybe I have the bias of novelty because it's always also one of our newest machine learning powered feature in production, is what one of my teams is working on. This is spoofing detection for our risk and compliance product. Okay, let me first give more context for your followers. Kpler is collecting, processing, and modeling data for the world commodity trade. A huge part of this relies on AIS data. Those are messages that ships on water send every other minute about their position, draft, and some other information. Those of you who are interested could visit our large audience-facing product, Marine Traffic, marinetraffic.com, which shows a map with the position of all ships in real time. Now, of course, what is more interesting to us is what the ship is transporting. If it's an liquefied natural gas, LNG tanker, it's easy to know since those vessels are very specialized in this commodity. With a dry bulker, it's much more difficult to know, and this is where my team is stepping in with pattern recognition techniques. Now, back on the spoofing detection, some ships actively falsify their positions. And one of the teams in my department released a spoofing detection pipeline that uses machine learning to determine if the ship is falsifying its positions using some well-known techniques. And this team has plenty of ideas how to build better and better detector for deceptive behavior in the whole spectrum of machine learning applications. It is what is brought to the game: image processing, time series modeling, modeling of mobility, graph machine learning, really name it. A lot of things are discussed and in different stages of development in our team, which objective is, of course, to complexify our first model that are already in production and found some non-trivial cases of spoofing that our clients were unaware of. Also, for some of the ideas we are looking in the research papers. We are also looking for a lot of inspiration in the vibrant OSINT community, and some of those folks publish their investigations showing they use marine traffic for it. Yes, this is a young product. We have got non-trivial cases of spoofing using nice machine learning techniques, and we are confident that people will speak of Kpler in the next months because of this.
So anomaly detection is one of your interests. Could you explain what anomaly detection is and also why it is crucial in your sectors?
Well, anomaly detection is a journey. I would tentatively say it's one of the most important data science applications, but usually not the most attractive. Well, when you work in a company like Kpler, whose business is to sell data, because we sell data, that's it.
Yeah.
Improving data quality is paramount. Let's consider some practical applications of anomaly detections, such as position spoofing. Half of the challenge is building anomaly detection system. Half of the challenge is formulating the problem, right? While anomaly detection on data from Excel sheets that our market analysts might be storing might be straightforward, but it is really engineering features from the state-of-the-art of processing and modeling of mobility data is where our data scientists hit in and provide the greatest value and provide a whole new perspective on the problem.
And so with anomaly detection, how do you integrate anomaly detection models with other data science techniques at Kpler to provide thorough insights?
Well, anomaly detection is, I have mentioned, a set of different techniques rather than only one. What is essential here is to integrate anomaly detection in relevant pipelines. With or without humans in the loop, this solution might be useful if your model is raising a lot of false positives, but is still reducing the volume of data to check. This is, I think, a common problem that comes with imbalanced data sets. But I would say that other parts are equally important, which are thinking about how those anomalies are notified.
Mm-hmm.
Like, how do you notify an anomaly to a human operator? How do you raise an alert? And in a most internal to machine learning to data science department problem, how do you make a good use of those detections to improve the pipeline or to train even other data science models and to put them in your pipelines? So this is why closely integrated business logic with machine learning models in pipelines is, for me, the way to go in making good use of any machine learning based approach.
So how do you approach the challenge of distinguishing between genuine anomalies and noise in the data then?
This is a very hard topic because all outcomes of a model result from the training of the model.
Okay.
And just as a large language model hallucinates, an anomaly detection model could generate noise or false positives. The underlying mechanism is pretty much the same. Just like the next word in the sentence is not the right one, it's completely hallucinated. Your anomaly detection can hallucinate an anomaly when there is not an anomaly.
Right.
Well, this is a side effect of having a useful model. It will always be wrong somewhere. I would say that building a proper notification system to make humans intervene and collecting feedback from your users, from your internal users, and improving your models, so making your model development a journey, is the way to go and the most obvious choice here.
So where, and now steering a little bit away from anomalies and anomaly detections, where do you see the most exciting opportunities for growth and innovation at Kpler over the next coming years?
We have pretty exciting opportunities in every data science team in Kpler.
Okay.
As I have mentioned, the detection of deceptive behavior, but I would also like to mention that in the last months, we have built a very strong team on remote sensing. This is processing of satellite imagery with data scientists who master this niche sector. And they have done incredible work and with excellent synergy with product data engineering, software development. And I think this is the best way for a team to function. And I think that the commodity trading sector will hear about remote sensing applications from Kpler in future. Remote sensing is a quite interesting topic. It's super interesting to apply data science on satellite imagery, since first it requires niche knowledge on pre-processing of the data from satellite, building specialized computer vision models to extract the data relevant to your product. And here hit again all the challenges that come to scale, because those images are served by fluxes that imply huge volume not necessarily every time relevant images, with some anomalies that could come along the way, like glitches in the satellite orbit, stuff like this that you should be able to detect before serve your results to the customer. So when your objective is to provide customers data faster and with better quality, and you want to do it for many sites on Earth, well, there is a definite both scaling and data quality challenge. As I have mentioned, a lot of improvements will come in modeling the vessel mobility side, pattern detection for commodity vessels, container vessels. Of course, I cannot go into the more detail about our roadmap, but it really is a pretty exciting moment to do AI for Kpler right now.
Yeah, sounds like it. Sounds like there's a lot going on over at Kpler as well. So it seems like since the last time I actually spoke with you guys, it seems like you guys have done a lot over the past sort of year or so as well. Now, looking back, Peter, do you have any kind of regrets about your career or academic choices, or has everything contributed positively to where you are today?
Well, I'm an overthinker, so I always have regrets.
Oh, I'm exactly the same. Don't you worry, Peter.
Yeah, actually, for my path, my choice of doing a PhD in physics is one of the few topics on which I don't have regret. Maybe I'm biased because it's my personal journey,
Yeah.
but the critical thinking my PhD brought to me is a great asset to me.
And I feel like it's definitely helped with the trajectory of your career and get you to where you are now, hasn't it? It's definitely
Definitely,
a good topic to have a
definitely.
PhD
Of
in.
course, being curious, questioning yourself. This is why I'm overthinking sometimes, but also I'm questioning myself. I'm admitting I might be wrong. This is how I'm moving forward, and it's all about critical thinking.
Oh, absolutely, especially in physics. And just finally, just to wrap up this podcast, do you have what advice would you give to people looking to enter the field of machine learning and data science?
Well, I think of three advice. The first two, I will put some knowledge from a famous physicist. Well, which one I will leave it to the audience as an exercise. Okay, first, I think that data science cannot be done without enthusiasm for knowledge of the field to which data science is applied. So my first advice is really be passionately curious. That's one thing.
Right.
Second, never abandon critical thinking. And always remember that the easiest person to fool is yourself. Some approaches will be unfructuous, some negative results will come up. Negative results are results. You should learn to adapt to what you see and not try to adapt what you see to what you believe. This is also a very important guideline for me. And third, and I have always touched this strongly in this discussion, never forget that the model will start to behave differently from what you saw in your notebooks from the very first moment it starts delivering results to the customer. So from very early on the design stage, think of how it will be evaluated in real life conditions and care about production.
Amazing. Well, there you have it. Thank you for everything that you've shared with me today, Peter. It's been very, very interesting, and thank you so much for joining me on today's episode of Vision to Venture. It's been an absolute pleasure having you on.
Same for me, Eddie. Thank you.
Thank you for tuning in to this week's episode of Vision to Venture. If you're listening, make sure to give us a 5-star review. And if you're watching, like and subscribe to listen to more inspiring stories from leaders in the tech space.